Peace be upon you and God's mercy and blessings. Let's now take a look together at the operation sequence setting inside the brake analyzer device. I will talk about two operation sequences, which are the closing sequence and the open sequence. As for the closing sequence, we have only one setting, which is the close pulse. So let's see how the idea works to know how to set this correctly. Now, when I start the close command for the circuit breaker through the breaker analyzer, the normal open contact responsible for the close command will then engage, which in turn delivers the controlled sublife voltage to the circuit breaker's closing coil. This command lasts for a period equal to the close pulse. During the close pulse, the close coil is at high voltage, which is the control supply voltage. Does the close coil need to remain energized until the breaker closes? No, of course not. As soon as the close coil engages and releases the circuit breaker spring mechanism, its role is finished, and the circuit breaker spring mechanism becomes responsible for closing the circuit breaker. Therefore, as you can see, a pickup occurred, and after that, the command is no longer relevant for the circuit breaker. From the moment the pickup happened, the mechanism started moving, and as you can see, the breaker closed after the command ended because it is not related to the continuity of the command on the closed coil, but only related to the fact that the closed coil picked up and released the spring mechanism. The close time is considered to start from the moment of the close command to the feedback I receive from the main poles of the circuit breaker. That's why we can say that the close pulse can be set to a duration of about 30 milliseconds or 50 milliseconds, as long as it is sufficient time for the closing cue to pick up. For the open sequence, the breaker analyzer device begins to issue this command sequentially based on the settings you have provided. The first thing I have is the open command. As soon as I issue the open command, the breaker analyzer closes the normal open contact responsible for the open command, which in turn connects the control supply voltage to the circuit breaker trip coil. So, how long does this command last? This command lasts for the duration of the first setting I have, which is the open one pulse. The duration of this pulse does not necessarily have to equal the open time of the circuit breaker, but it must be sufficient for the trip coil to pick up and release the spring responsible for opening the circuit breaker. I will set this duration to 20 milliseconds. The opening time of the circuit breaker will be from the moment the circuit breaker opens until the moment it opens from the pulse. So when will the close command be issued? We agreed that I must leave a time gap between the operation of opening the circuit breaker and closing it again. This time was written on the circuit breaker's nameplate and was equal to 0.3 seconds. Therefore, my second setting is the time between the positive edge of the first open command and the positive edge of the close command, which will be... After that, the close command will be issued and will continue for a period equal to the third setting, which is the close pulse. Set it to 20 or 30 milliseconds. The important thing is that it is a sufficient time for the close coil to pick up and release the spring that closes the circuit breaker. Moment. Closing the circuit breaker main poles. So, when will the other open command be issued? We can say or assume that during the breaker's operation, it encountered a fault and an arc occurred on the breaker poles. Therefore, the protection trip command was issued. For this fourth setting, which is the time from the moment of the positive edge of the close command to the moment of the positive edge of the second open command, we will set it, for example, to 30 milliseconds. This is considering that the circuit breaker's closing time is about 40 milliseconds, and this is for the circuit breaker I am working on from LS Company. In this case, the breaker is supposed to open again after the main poles close, and we must ensure something very important during the test. You might find the necessity in the open time to be about 10 milliseconds longer. Why is this? Because, as we saw in the circuit breaker video, the trip spring must be charged during the mechanical movement of the circuit breaker while it is closing. And this is, of course, through the discharging that occurs to the circuit breaker's closed spring. So naturally, you have inertia that you want to charge, and then it happens. With this, we have been able to discuss it in detail. And hopefully, in the next video, we will see together how I can read what comes out from a device or a device. The report that will come out from the Egil device or the breaker analyzer